So let us consider problem number 2. Given the following data of the slip critical tension connection shown with 22 mm diameter bolts in standard holes with threads excluded from shear planes, considering the plates only, compute the design tensile strength using LRF di sempre and the allowable tensile strength from the word itself allowable. So gagamitin natin dyan is ASD using NSCP 2015. Fy is equals to 248 megapascal. Fu is equals to 400 megapascal. So for this problem, consider natin to. So mangyayari niyan is meron tayong plate na nakasandwich sa dalawang plate. So, yung plate natin sa gitna o yung middle plate natin, that has a thickness of 22 mm. Samantalang yung mga side plate natin, yung mga plate natin sa taas at saka sa baba, that has a thickness of 12 mm. So, yung 22 mm, nakasandwich siya sa pagitan ng dalawang 12 mm na plate. So, for this one, siyempre, kung hahatakin natin yung middle plate natin with a force P o yung tensile strength natin na P, therefore, yung sa side plate natin, sa upper at saka sa lower, siyempre, pagtutulungan niya etong middle plate natin, so that will become P over 2 sa taas and also P over 2 sa baba. So, meaning to say, yung force natin going to the right, which is equal to P, siyempre, ibabalance siya ng dalawang side plate natin na P over 2, which is also equal to P. So, for this one, ito yung top view ng mga plates natin. Tapos, kung titingnan natin sa side view niya, ito yung mangyayari niyan. So, top view, side view. Top view, front view pala to. So, mangyayari is makikita natin na yung mga plates natin, it is connected by 3 bolts. By 3 rows of bolts. So, yung row 1, row 2, at saka yung row 3. So, for this one, parang column, no? This is column 1, column 2, at saka column 3. So, whatever. Basta, it is connected by series of bolts. So, for this one, siyempre, we will going to solve based on yielding muna tayo. Okay. Or based on gross area. So, when we are talking about yielding, gross area yung ginagamit natin in computing for the value of your nominal strength. So yung nominal strength natin, that is equal to Fy multiplied by the gross area. So for this one, ko-consider natin yung dalawang case. So first, kung i-consider natin yung side plate muna. So if we were going to consider yung side plate or yung mga upper and lower plate. So for this one, let's say, yung consider natin yung upper plate natin. So yung dimension niya, that is 350 by 12 mm. So, makukuha natin yung value ng gross area natin. That is equal to 350 multiplied by 12. Kasi yung 350 na tinutukoy natin dito is eto. So, yung 350 na plate natin, yung width niya, that is 350. Tapos, yung thickness naman niya, which is eto, that is equal to 12 mm. So, the value of your gross area is now equal to 4,200 square millimeter. And, titingnan nyo dito sa ano natin, yung nominal natin, that is divided by 2. Kasi nga, yung P natin, it is divided by 2. Kasi etong tensile strength natin, yung mangyayari is it will be divided by pagtutulungan siya ng upper at saka yung lower plate. So, yung nominal natin that will be equal to P sub n all over 2 is equal to yung Fy na gagamitin natin, that is 248 multiplied by the gross area na 4,200. So, the value of your nominal is equal to 2,083.2 kilonewton. And siyempre, yung susunod na i-consider naman natin is the middle plate. So, yung nakapagitnang plate natin na merong dimension na, so yung middle plate natin, ito yan. So, that has a width of 350 by 22 thickness naman. So, yung width niya, that is 350. Same lang siya ng width sa side plate. So, 350 by 22 naman to. So, AG, that is 350 multiplied by 22. So, the value of your gross area is now equal to 7,700 square millimeter. And kung titingnan natin, etong middle plate natin, yung nominal natin dyan, that is isa lang. Hindi siya naka-divide by 2. So, that is P or P sub n. So, yung Fy natin, that is 248 multiplied by the gross area na 7,700. So, the value of your nominal is now equal to 1,909.6 kilonewton. So, for this one, no, between the side plate na nakuha natin na nominal na 2,000, tapos dito naman sa middle plate na 1,909, so yung ko-consider natin dyan is the lower value. So, we will going to use the lower value. Therefore, P sub n on the gross area, that is equal to 1,909.6 kilonewton. So, for this example, yung nag-govern sa design natin is etong nasa middle plate natin. Kasi, yung middle plate natin hanggang 1,909.6 lang yung kaya niya. Kaso yung kaya ng mga side plate natin is 2,083.2. So yung mag-a-adjust siyempre yung side plate natin, kasi yung side plate natin kakayanin niya yung 1,909.6 kasi nga yung capacity niya is hanggang 2,083. So after considering yielding, we will going to consider rupture, or tinatawag din natin yung rupture natin na fracture of the net section. Fracture or yung rupture natin. So for this one, siyempre we will also consider yung side plate at saka middle plate natin. We're in computing for the value of your nominal, that is equals to FU since it is fracture, tapos yung effective net area natin. So, for this one, magkakaroon na ng effect etong mga bolts natin dito sa plate natin. Kasi yung gagawin natin is kukunin natin yung net width para makuha natin yung net area. Tapos, para makuha natin yung effective net area. So, mangyayari kasi is magkakaroon tayo ng critical section sa mga butas natin. So, for this one, and we will going to project, no, yung ano natin dito, area natin. So, yung buong width niya, that is 350. Tapos, ayan. So, kung titingnan natin siya dito sa side natin, kung titingnan natin siya sa side, so, mangyayari niyan is meron tayong tatlong butas, 1, 2, yung nasa gitna, at saka yung sa baba naman. Okay. So, for this one, ito yung mga diameter of holes natin, which is shaded by red. So, for the diameter of our hole, or that is our D sub H, that is also equal to, para shortcut na lang, kasi mangyayari niyan is, meron tayong diameter dito na, ano ba, 22 mm, yung diameter ng bolt natin. Siyempre, magkakaroon tayo ng allowance dito na tigda 2 mm. So, mangyayari niyan is, yung value ng diameter of hole natin, that will be equal to 22 plus 4. So, mangyayari niyan, that is 22 plus 4, that is equal to 26 mm. So, kunin muna natin yung mga net area natin. So, first of all, let us consider etong sa side plate muna. So, considering side plate, kunin natin yung net area natin. So, for this one, yung buong width, so side plate muna tayo. So, consider natin etong part na to. So, yung buong width niya, that is 350. So, yung buong ano niya dito, that is 350. So, 350 minus, so kung ilang butas yung makikita natin, so we have 1, 2, at saka 3. So, yung dimension ng kada butas natin, that is equal to 26, 26, and 26. So, multiplied by 26. So, ito yung net width natin multiplied by the thickness. So, yung thickness ng plate natin, considering the side plate, that is equal to 12 mm. So, the value of your A sub n is equal to 3264 mm squared. So, for this one, let us assume na yung value ng ano natin, for simplicity lang, let us say na yung A sub n natin, that is equal to A sub e. Sabihin natin na yung value ng reduction factor natin, that is equal to 1.0. So, assume lang natin, no? So, siyempre, yung A sub n natin, that must be less than to the value of your 0.85 Ag. So, yung value ng 0.85 Ag, that is equal to 0.85. Yung Ag na nakuha natin, which is yung 4,200. So, which is equal to 3,570. Since less than siya, okay yung magiging A sub n natin. So, makukuha na natin yung value ng P sub n natin. So, for this one, yung nominal natin, yung FU that is 400, multiplied by A sub E natin. So, for this problem, in-assume natin that A sub E is equals to A sub n. So, we have 3,264. And for this one, since yung P natin dito sa mga side plate natin, that is P over 2. So, mangyayari niyan dun sa nominal natin, madi-divide yan by 2. So, the value of your P sub n is equal to 2,611.2 kilonewton. Siyempre, kung kinonsider natin yung side plate, we're going to consider also yung middle plate natin. Okay. So, for this one, kunin natin yung net area natin. That is equal to, so same lang sila ng width ng side plate natin, wherein dito sa middle plate natin, yung width niya, that is also equal to 350 minus, so kung ilang butas yung makikita natin, so we have 3, 1, 2, 3. So kung i-consider, ito yung side plate natin, so ito yung top view, tapos etong part na to, ito naman yung middle plate natin. So meron tayong 3 butas na makikita dito, 1, 2 3 multiplied by the diameter of the hole. Tapos, yung thickness naman nito, that is equal to 22 mm. So, the value of your A sub n is now equal to 5,984 mm squared. So, for this problem, let's say A sub n is equals to A sub e, wherein yung A sub n mo dapat, that must be less than 2.85 of Ag, wherein yung value ng natin dito, 0.85 multiplied by Ag, dito sa middle plate natin, which is equal to 7,700. So, the value ng 0.85 gross area natin is equal to 6,545 mm squared. Since less than yung value ng A sub n natin sa 0.85 Ag, therefore, okay yung area natin. So, yung value natin, that is nominal, multiplied by yung FU natin, which is equal to 400, and yung nakuha natin na net area na inassume natin na same sila ng effective net area natin. So, for this one, we will going to use the effective net area, which is equal to 5,984. So, P sub n, that is equal to 2,393.6 kilonewton. So, for this one, same lang tayo dito, no? Gagamitin din natin between these two na nakuha natin considering the side plate at saka middle plate, we will going to use the lower value. So, use lower value. Therefore, yung P sub n na gagamitin natin is yung nasa middle plate natin. So, that is equal to 2,393.6 kilonewton. So, yung middle plate natin, ito yung nag-govern sa design natin. So, ito yung nag-govern. So, nakuha na natin yung sa yielding natin na nominal. And at the same time, yung nominal natin, nominal strength natin sa fracture or rupture. So, ngayon, kukunin natin yung design tensile strength natin at saka yung allowable tensile strength natin. So, using sa design tensile strength, using LRF dito, allowable tensile strength naman, using ASD naman, yung gagamitin nating approach. So, tatandaan lang natin yung mga reduction factor na gagamitin natin, and at the same time, the value ng mga safety factor natin under yielding and under sa fracture or rupture. So, let's solve for the value. So, dito muna tayo sa yielding using LRFD. So, sa yielding tayo o yun sa gross area natin. So, that is equal to yung P sub U natin, that is reduction factor multiplied by the nominal. So, for this one, yung reduction factor natin under yielding, that is 0.90. And yung nominal natin, that is 1,909.6 kilonewton. So, the value of your design strength sa yielding is equal to 1,718.64 kilonewton. So, how about naman sa counterpart niya sa ASD? Yung allowable tensile strength natin, which is denoted by P sub A, that is equal to P sub N, divide natin siya by a safety factor. So, we have 1,909.6, and yung safety factor natin sa yielding, that is equal to 1.67. So your allowable tensile strength, considering yielding, is now equal to 1,143.47 kilonewton. So next naman is using naman sa rupture naman natin or fracture. Rupture or the fracture on the next section. So that is same lang. PU is equals to P multiplied by the nominal. Kaso nga lang, yung reduction factor na gagamitin natin dito, that is equal to 0.75. So we have 0.75 multiplied by the nominal na nakuha natin. So that is equal to 2,393.6. So the value of your design tensile strength is equal to 1,795.20 kilonewton. Using naman sa ASD natin, so we have yung allowable natin, yung piece of L natin, i-divide natin yan by a factor of safety. So yung piece of L natin dito, that is equal to 2,393.6. Yung safety factor naman natin under rupture, that is equal to 2. So the value of your allowable tensile strength, that is equal to 1,196.80 kilonewton. So for this one, so i-consider natin dito na design tensile strength. So meron tayong nakuha na dalawang value. So yung unang value natin dito, etong 1,718.64 at saka etong 1,795.20. Siyempre, yung i-adapt natin dito is the least value. So eto yung design tensile strength natin. Next naman, same lang tayo sa ASD. So we have to, etong 1,143 at saka 1,196. Siyempre, kukunin natin dito na value is yung least value. So this will now become your allowable designs. Okay? So ganun lang yung pagkukonsider natin sa mga tensile strength natin using LRFD and using ASD.